Euclid's Elements, Book 1, Prop 27. If a straight line falling on two straight lines make the alternate interior angles equal to one another, then the straight lines will be parallel to one another. So let's have two straight lines. Call this line AB, call this line CD. And let a straight line fall on these two straight lines. We'll call this EF, such that it makes the alternate interior angles equal to one another. We call these angles alternate because they're on the other side of this line, and they're interior because they're on the inside of lines A and B. So these are alternate interior angles. So if it's given that we have these three lines, and if it's given that angle AFE is equal to angle FED, then we can prove that AB is parallel, this is my little symbol for parallel, is parallel to CD. We start this proof by saying, I say that this is true, that AB is parallel to CD. Because if it isn't parallel, if it's not parallel, we know that non-parallel lines will meet on the inclining side. So if they're not parallel, then they must incline to one another, and therefore they will meet on one side. So they'll meet on one side. Either they'll meet on side AC, or they'll meet on side BD. And we can show that in either case, this leads to a contradiction. So let's just choose at random that they meet on side BD. So this means if we extend lines B and extend lines D, at some point they meet. And if they meet, and I know it doesn't quite look like it here, but if they're inclining to one another, at some point they will meet and they'll make a giant triangle. So this is the base and these are the legs of our giant triangle. Well, if this is a triangle, then this is the exterior angle to this triangle because it's one of these legs extended. So let's call this, label this for ease here, we'll label this angle 1 and we'll label this angle 2. So Book 1, Prop 16 says that an exterior angle, so exterior angle 1 has to be greater than the opposite interior angle, angle 2. But it's given that these angles are equal to each other. Therefore, angle 1 is equal to angle 2. But we're saying that angle 1 is both greater than angle 2 as the opposite angle is greater than the opposite interior angle. The exterior angle is greater than the opposite interior angle and also equal. They can't be equal and greater at the same time. This leads to absurdity. Therefore, they do not meet on side BD. Similarly, we can prove that they don't meet on side AB, right? We extend these and they would have to meet on this side. And then this becomes the exterior angle. Exterior angle 2 has to be greater than the opposite interior angle, angle 1, but they're also equal. Angle 2 is also equal to angle 1. Therefore, it's both greater than and equal. Therefore, they don't meet on side AC. And if they don't meet on side BD and they don't meet on side AC, then they don't meet. And definition 23 of Euclid's Elements tells us that lines that don't meet are parallel. These lines don't meet on either side, therefore they are parallel. Therefore, AB is parallel to CD. And since we've proved that, we conclude with QED.